Now, we can use all the comparison operators you have learned so far with pointers, but you have to remember that you're essentially comparing addresses. Here's an example. Let's declare two integers, x and y, as well as two integer pointers. We can call the first one ptrx and have it point to x, and the second one ptry pointing to y. Now, if we write an expression like ptrx less than ptry, we are essentially comparing the addresses stored in these pointer variables. If you want to compare the actual values like 10 and 20, then we have to dereference these pointers. It doesn't mean we always have to dereference our pointers when comparing them. Sometimes we want to compare addresses. For example, let's change ptry and have it to point to x. So now we have two pointers pointing to the same variable. So we can write a Boolean expression like if ptrx equals ptry, that means both these pointers are pointing to the same location, then we can print a message like same. So now when we run our program, we see same on the terminal. Another case for equality comparison is avoiding null pointers. So as a best practice, whenever we want to use a pointer, we should make sure it's not a null pointer. So over here, let's dereference ptrx and print it on the terminal. So we are using this pointer, but before doing so, we should make sure ptrx is not a null pointer. So here we write an expression like this. If ptrx is not null pointer, then use the pointer. Now here's a little exercise for you. Assuming that we have an array of integers, create a pointer that points to the last element in this array. Then using a while loop, iterate over this array and print each number in reverse order. So we should see 30, 20, and 10. Spend a couple minutes on this, then come back see my solution. All right, so here we have an array of integers. Now I'm going to declare an integer pointer and initialize it with the address of the last element in this array. That is numbers of 2. Now, alternatively, we can write this in a more generic way. So instead of hard coding this index, we can get the size of the array and subtract 1 from it. That's better. So here's our pointer. Initially, it's going to point to the last element in this array. Then using a while loop, we're going to iterate over this array. And in each iteration, we're going to print the current number and then decrement the pointer to point to the previous element. And we're going to do this while this pointer is greater than or equal to the first element in this array. So we're going to write a while statement. I forgot a semicolon. So while pointer is greater than or equal to the address of the first element. That's one way to write this expression. Or we can just type numbers because this is a pointer to the first element in this array. Okay. So now we are comparing two pointers. And there is no need to dereference these because we're comparing addresses, okay? So in this while loop, we're going to print, here we're going to dereference the pointer, and then we're going to decrement it to move it to the previous element. So now when we run our program, we see 30, 20, and 10. Beautiful.